Chapter 7 Angles Point, line segment, line and ray. Point. Observe the figure on the right. It shows a slate on which you write. Its corners are P, Q, R and S. Each corner gives us the idea of a point. We use a dot to represent a point. A capital letter is used to name a point. For example, P, Q, R and S are 4 points marked here. Line segment. Let us mark 2 points A and B on a paper. We place our scale in such a way that one of its straight edges touches both the points. We now place our pencil at A and move it from A to B along the edge of the scale. We get a figure as shown on the right. It is called a line segment AB. So, a line segment has 2 endpoints. It also has a definite length. We write line segment AB. A line segment is a straight line that has a beginning and an end. Line. A long straight road which seems to be endless gives us the idea of a line. In the figure, a line segment is drawn which is extended infinitely, endlessly on both sides. A line segment which extends on both sides infinitely, endlessly is called a line. So, a line is endless. It has no endpoints. It does not have a definite length and we represent line AB. Ray. The light coming from a torch or sun gives us the idea of ray. Let us represent a line AB on the paper. Let us mark a point O on the line AB, somewhere in between points A and B. The point O divides the line AB into 2 parts. Each part together with O is called a ray. Example, ray OA and ray OB. So, a portion of line which extends infinitely in one direction only from a point is called a ray. The point is called the end point of a ray. Thus, a ray has only one end point. We represent a ray OA. Let us now tabulate the differences between a line segment, a line and a ray. A line segment, a line, a ray. 1. We can draw a line segment on the surface of a paper. We cannot draw a line on a paper but can only represent it. We cannot draw a ray on a paper but can only represent it. 2. A line segment has a definite length. A line segment does not have a definite length. A ray does not have a definite length. 3. A line segment has 2 endpoints, AB. A line segment does not have endpoints, AB. A ray has only one endpoint. The above line segment is represented as line segment AB. It can also be represented as line segment BA. The above line is represented as line AB. It can also be represented as line BA. The above ray is represented only as ray AB. Do these. 1. 1. Which of these are line segments? Representation. have won. You have won. Oh no, do it again. Two, name the line segments. Communication. Three, identify the lines and rays in the following. Reasoning proof. Angle. When two rays meet at a point, an angle is formed. The point where the two rays meet is called the vertex. The rays form the arms of the angle. The following angle has vertex O and arms OB and OA. It is called angle BOA. It can also be named angle AOB. The symbol represents the word angle. Remember, while naming an angle, the vertex should always in the center. We can also name an angle in a different manner. Consider the following angles. Here, angle ABC can be represented as angle 1. Here, angle XYZ can be represented as angle A. Example. Suggest few examples that make you think about angle. Solution. A. Two hands of a clock. B. Two arms of a scissors. C. Two arms of a divider. Interior and exterior angles. Figure 1. Figure 2. If two rays with the same endpoint, figure 1, and two line segments with a common endpoint, figure 2, are drawn, then two angles are formed. One of them is called the interior angle and the other the exterior angle. From figure 1, angle 1 is the interior angle and angle 2 is the exterior angle. From figure 2, angle X is the interior angle and angle Y is the exterior angle. Do these two. 1. Which of the following figures represents an angle? Representation. Two. Name the vertex and the arms of each of the angles shown in the figures below. Communication. Three. Name all the angles in each figure. Communication. Four. Name the interior angle and the exterior angle in each of the following. Communication. Measuring angles. The standard unit for measuring an angle is the degree. The mathematical symbol for degree or degrees is degree. To measure an angle in degrees, we use a protractor. In a protractor, we notice the following. It has one curved edge in the form of a semicircle and one straight edge. The semicircle is divided into 180 equal divisions and each division represents 1 degree. The divisions are marked at intervals of 10 degrees from 0 degree to 180 degrees, both clockwise and anti-clockwise directions. The line segment joining 0 degree and 180 degrees is called the baseline of the protractor. The midpoint of the baseline is called the center of the protractor. To measure an angle, say angle AOB, we proceed as follows. A. Place the center of the protractor on the vertex O of the angle. B. Adjust the protractor such that the baseline of the protractor falls along one arm of the angle, say OB. This arm shows the 0 degree mark. C. Read the mark on the curved edge of the protractor through which the other arm OA passes. In this case, this mark is 50. So, the measure of angle AOB is equal to 50 degrees. Types of angles. Basing on the degree measures, angles are classified as follows. 1. Right angle. An angle whose measure is 90 degree is called a right angle. 2. Acute angle. An angle whose measure is between 0 degree and 90 degree is called an acute angle. It is less than a right angle. 3. Obtuse angle. An angle whose measure is between 90 degrees and 180 degrees is called an obtuse angle. It is more than a right angle. 4. Straight angle. An angle whose measure is 180 degrees is called a straight angle. One straight angle is equal to 180 degrees or 2 right angles. The arms of a straight angle are opposite rays. 5. Zero angle. An angle whose measure is exactly 0 degrees is called a zero angle. Rays PQ and PR coincide. So, angle QPR is a zero angle. 6. Complete angle. An angle whose measure is 360 degrees is called a complete angle. In the figure, there are 4 angles. Angle AOB, angle AOD, angle DOC and angle COB. They are all of 90 degrees. Hence, starting from OA and reaching again at OA, there is one complete revolution or it is a complete angle. One complete angle is equal to 360 degrees or 4 right angles. 7. Reflex angle. An angle whose measure is more than 180 degrees and less than 360 degrees is called a reflex angle. While comparing angles, we conclude A. A right angle is greater than an acute angle. B. An obtuse angle is greater than a right angle. C. An obtuse angle is greater than an acute angle. Do these. 3. 1. Use your protractor to find the degree measures of the following angles. Communication. Two. Classify the following angles without measuring. Use your protractor to check. Reasoning proof. Three. Classify the angles whose measures are given below. Reasoning proof. Comparison of angles. We can easily compare the two angles given below. We can easily see that angle BAC is greater than angle EDF, since the degree measure of angle BAC is 60 degrees, while that of angle EDF is 50 degrees. We can also take angles without measuring. This method is called tracing method. Here, we may take the following steps to compare the angles. 1. Copy the angle PQR on the tracing paper. A. PQR. B. LMN. 2. Place the traced angle PQR over the angle LMN so that Q falls on M and arm QR falls on MM. 3. If the arm QP lies below the arm LM, we say that angle PQR is smaller than angle LMN. If the arm QP lies above the arm LM, we say that angle PQR is greater than angle LMN. If the arm QP falls along the arm LM, we say that angle PQR is equal to angle LMN. Constructing angles. Let us draw an angle of a given measure using the clockwise as well as anti-clockwise reading of the protractor. Let us draw an angle XYZ of a given measure of 70 degrees using the anti-clockwise reading of the protractor. Step 1. Draw a ray YX. Step 2. Place the protractor with its center at Y and the baseline along YX. Step 3. Read the inner scale or the anti-clockwise reading and mark a point Z against 70 degrees mark on the paper. Step 4. Remove the protractor and draw the ray YZ. Angle XYZ is the required angle of 70 degrees. Thus, angle XYZ is equal to 70 degrees. We can also draw an angle XYZ is equal to 70 degrees using the clockwise reading of the protractor. Step 1. Draw a ray XY with its end point Y to the right. Step 2. Place the protractor in such a way that its center is on the end point Y and its baseline is along ray YX. Step 3. Mark a point Z against the 70 degree mark on the outer clockwise reading of the protractor. Step 4. Remove the protractor and join point Y with point Z to get angle XYZ is equal to 70 degree. Thus, angle XYZ is equal to 70 degrees. Do this. 4. Use your protractor to draw these angles in both clockwise and anti-clockwise reading of the protractor. Representation. Pairs of related angles. Complementary angles. Consider the two angles, angle ABC and angle XYZ. Angle ABC is equal to 60 degrees. Angle XYZ is equal to 30 degrees. So, angle ABC plus angle XYZ is equal to 90 degrees. Two angles, the sum of whose measure is 90 degrees, are called complementary angles. Angle ABC and angle XYZ are complementary to each other. If angle PQR is equal to 25 degrees and angle MNO is equal to 65 degrees, then angle PQR and angle MNO are complementary angles. Supplementary angles. Here, angle ABC is equal to 120 degrees and angle XYZ is equal to 60 degrees. So, angle ABC plus angle XYZ is equal to 180 degrees. Two angles, the sum of whose measure is 180 degrees, are called supplementary angles. Angle ABC and angle XYZ are supplementary to each other. If angle PQR is equal to 110 degrees and angle MNO is equal to 70 degrees, then angle PQR and angle MNO are supplementary angles. Adjacent angles. Look at the two angles, angle AOB and angle BOC in the figure. They have a common vertex 0 and a common arm OB. The other arms of the angles are on the opposite sides of the common arm OB. Such angles form a pair of adjacent angles. Vertical angles. Consider two lines AB and CD that intersect each other at O. They form four angles: angle AOC, angle AOD, angle COB, and angle BOD. Angle AOC and angle BOD are called vertical angles. Angle COB and angle AOD are called vertical angles. Notice that angle AOC and angle AOD are adjacent angles. Angle BOC and angle BOD are also adjacent angles. Do these 5. 1. Identify which of the following pairs of angles are complementary or supplementary. Reasoning proof. Two. Find the complement of each of the following angles. Problem solving. Three. Find the supplement of each of the following angles. Problem solving. Four. Which of the following are adjacent angles? Which are vertical angles? Reasoning proof.